Okay, so that's pretty good. Uh, I have another slide. I, this might give you some insight of what it actually is. So on the left, you have some load applied to it and reaction to it. And on the right is some values given for rubber, steel, and cork. Just comparing these two images can give you some insight. I see a few interesting answers. Even if it was I would have given the same answer. But let me give you some insight to it. So you have a material and you give some load to it, which is shown in red, applied external force. So for the force, there's some reaction, right? So that's what is shown in red down here, black down here. So looking at the values, you can definitely say that the value of cork is 0 and for rubber is zero point 0.5. So it actually signifies how it can expand or stretch. So when you look at a cork, uh, even if you give any loading, it's not going to stretch out, but it's a total opposite way for rubber. So when you give some loading, it's just gonna have some, it's gonna stretch out. So that is why Poisson's ratio is always in the range of 0 to zero point 0.5. So this is the maximum value you would see for a Poisson's ratio. So a cork which can't have which can't stretch out has value of 0, and the maximum value for Poisson's ratio is for rubber, which is zero point 0.5. So where the steel lie is it's between them, it's zero point 0.3. So steel has property to stretch, so that's why it's between that. So that is what Poisson's ratio is. So when a material is stretched in one direction, so I have another image down here that's it's giving a tensile load. When a material is stretched, it usually tends to contract in a direction opposite to the direction of stretching. So that is what Poisson's ratio is. So it's the effectiveness of its stretching. So and this would be another and this would be an other image to explain you Poisson's ratio. Answer why cork is used, please. Yes, so the reason is because you don't want you have your champagne which is so costly. Okay, so you don't want any leaks to it, right? So uh, let's say I'm a champagne manufacturer, I manufacture it, I send it to some location. I don't want the champagne to be spilled out, right? So to avoid that, they use this cork so that the whatever load or stuff you give to it, it's not gonna like stretch out, wasting out the liquid. Yep. So and our question was that rubber is definitely leak proof. So when you use the rubber for this, you have to like come all the way around. You'll have to do some put them all the way around so that it doesn't leak. But cork is just like when you look at the structure, it will be within the champagne bottle, and you'll have to like pull with that's a separate opener you have to remove this cork. So when you have a champagne bottle, it will be interesting if you don't have a proper equipment to remove the cork, you would find it so difficult to remove this cork out of the champagne. So that's the reason why you don't want this costliest champagne to waste. So that's why they use the cork. So I thought this example can give you insight in both ways. So I hope this was an interesting one. Okay, with that said, uh, we have dealt with the two important properties of materials. One is elastic modulus and other one is Poisson's ratio. With that said, let's move on. In Ansys, what we would actually do is like take some real world example. So here is where you see an iPhone bending. So what we're trying to do simulate here is like hold the iPhone to it, give some load to it. So again, you could see the values are something different. You see a proper deformation going on. It's just like playing around with different values. When you give some different values, it's gonna stress and some is not gonna like deform at all. So this is a simulation showing you guys how we could run a simulation for iPhone bending. So this is one thing which we would cover during our classes.